Hello. Um, I've decided that you you should to do homework before control work, and control work will be and control work will be on the next week. Um, so let's consider today shortest path algorithms uh, on weighted graphs. The first algorithm. So when will the homework be due? Okay, no. Uh, Today or tomorrow, I send you to the chat homework. And today I prepare 3 tasks, 3 practice tasks, and I publicate it. And I will publicate it. So let's consider algorithm. Let's consider shortest path algorithm. So the first algorithm will be null k BFS algorithm. On weighted graph, we can I remind you we can find shortest path using DFS or BFS, but we consider weighted graph in this case, and weight function will be h from h to the null k minus null k minus 1. Oh, нет, just k. So we need to find a distance distances from S to all the vertices, so all vertices. So the first algorithm, it will be very so when k is small, this algorithm will be very effective. So notice that the length. Notice that the length of any shortest path less than nk. Nk is n is count of vertices, and why is that true? We have some graph, and we have paths in this graph, and why is any shortest path in the graph will be less than k. Because if we have because if we have n vertices, and suppose we have in that case we have n vertices and n minus 1 edges, and it just will be bamboo graph, and in this graph the worst case weight will be n minus 1 minus 1 k. I remind you that weight that by length we mean if we have some path, if we have some weight, length of this path will be this will be length. So the algorithm we create nk queues in and then in this queue is we store vertices which length less than no, just we store vertices which length from S is there just there. In the next algorithm we consider that length is less than the vertices which length the length equals to from S just is there. Okay, so we push to the first queue, we push S because it's obvious why we do this, and dist S equals to null. Dist S is function that stores minimum length just adverse for all the vertices. This means so vector ball we need to create vector ball that in which we store you store visited or unvisited vertices used and false. We allocate all of them as false. So the algorithm complexity will be onk plus n, but we have no before I start to write next following lines, I think it's very important that you it's you just you should to know that we have your own key OSM complexity. So this will be for 3 cycles, but we have this complexity. So we consider the that's just an index, just iterate through all the queues, and another cycle while current queue is empty. Is not empty. We just pop from it another vertex, and we try to just pop. And if we visited this vertex before, we just continue. We don't need to consider again this vertex before we do the iterate through all weights, and we get smallest and on the first iteration that considers this vertex will be the answer. So used is false. Contains answer, I mean. So if we didn't consider this vertical vertex, we consider all the edges from this vertex, and some x we try to do relaxation. You didn't know what is relaxation. It's just update. We try to update. We try to update minimum in this vertex, minimum shortest path in this vertex, from S to this vertex. If what? If new x less than previous answer, так, 1 second. Sorry. Так, okay. We try to calculate new answer. Try to update the answer. We just assign new distance x and push this vertex to the answer. Так, if, for, while, and for. So that's the algorithm. Let me consider example. For example, this example. Так, and we push S, then we try to do reclassation for this vertex and this vertex, and in the first by the way, dist of from S to everywhere is equals to infinity, and we just update it. So так, we in the first iteration we pop this vertex, only this vertex of this cycle, and on the second iteration we get that this vertex will be this path will be the shortest path because we update it this on second iteration of this form, and and on third iteration we just continue. We pop this vertex and continue. So do you have questions about this algorithm? Okay, complexity. Why is complexity on key plus m? Each vertex will be once in every queue, and we get that we push to every queue m, we push m times to every queue vertex in this block of code, or if we get less than, we get nk greater than m, we just iterate through. We do iteration through all the queues, get and key. I mean, if M is dominates then n key, it will be OM. Other keys it will be on key. So I hope I explain complexity. So the next algorithm we will use похожую идею. We given weighted directed graph, and GVE. We have function where it works from E to null plus infinity. And we need to find distance. Find distances again from S to all vertices. No, shortest path. Distances is shortest path. Or shortest path. So in this case, in this algorithm, we consider two sets, S and Q. In S we store used vertices. That is for these vertices, our function dist is true. We have true shortest path, not estimated path. And second case we have unused vertices that we have, and for this vertices we have estimated dist. By estimated, I mean upper bound for each upper bound of the length of shortest path. And so let me write Dijkstra algorithm. I forgot to turn on translation. So on the input we have J, function v and s. Before we start, we initialize all the. We need to initialize сейчас подумаю. 1 second. I think I need to do a function because we will use this function. Давайте, ладно, пишу внизу. We will use this function for the next algorithms. Initialize single source function for g for v for v belongs to gv. We just equal to all the just assign the distance by infinity, and the parent will be nil for all vertices, and SD will be null. What is this? We just we need to use this function in algorithms very often, and I just write to you this function, and in Dijkstra we just initialize single source. We use this function. Source for JS, and okay, and we get, and after that we have to we consider two sets. We initialize S2, Q we initialize as GV, and while it's a very simple algorithm. We just consider that while Q is not empty, we extract minimum from our Q, from our set Q, and add to our set U, because every time, because the first vertex in this Q extracted by minimum weight will have minimum distance, and we just push it to our set that we know that we know true distance. So after that we just iterate so all the children of u, and we try to do relaxation, and that's all. By relaxation I mean this function if the ud plus what? Plus cost we have the function, not cost, plus the uv, we get that vd equal to vd plus vu, and the parent is u. That's all. This function we call relaxation. Relax. Okay, relax. Very simple algorithm. Just notice that every time we by the way, q is set q we can implement by priority queue, and in this priority queue we can get extract min, and by weight, by minimum weight, and we get that this edge is this edge will be included in our shortest path, and it will be the last edge, because if we have some path that already in this that already contains in this set, that we already know that all the vertices in this path contains in S, and we have parents. We on each iteration we updated our path. And we know shortest path, and we try to do relaxation from some vertex just by minimum edge. I mean, we consider minimum edge, and it's obvious that this path will be shortest path, because we have in Q we have some vertices and we have some weights, and the less weight, the less minimum weight will be included in our path. Do you understand this algorithm or not? No, complexity will be you can complexity will be O m log n. You can ask questions about this algorithm. Why is it m log n? Because on each time in queue, in priority queue, we have only n vertices and we do relaxation, we try to do relaxation m times. No, and that's why we have log n, because we have because every iteration performs for log n or log n, and we have to consider m edges. That's why this complexity O m log n. Relaxation will be performed for O v. No, O n. And m is equal or greater, it is greater than n. Did you answer? Did you ask questions? Okay. I think it's time to have a break. I think. Maybe you ask some questions. Okay, continue. Let's consider example. We have some vertices and graph. Так. Okay, and we do initialization, initialize single source function, and we get this graph. So we will start with we push this vertex to our need to push this vertex in our S set. Then we just iterate through iteration and do relaxation to this vertex and this vertex. We'll get that this vertex will be 8 and 5. So we get this graph after we extract mean, extract this vertex by minimum weight, and we notice that we marked this as visited, and we do relaxation, get that it equals to 7. Okay, after it equals to 8. After this we we push again this we extract mean again this vertex and mark it as notice, and so on. We relaxate this and do relaxation for this before we start to push, and we continue we continue to do this algorithm again and again So each time in in uh, in minimum of this set of this priority queue, we have right edge. We have right. No, we have smallest pass. We have edge with smallest pass that go to vertex with, and this will be smallest pass. So I forgot something, I think, or not. Okay, that's okay. Do you have questions? Что я написал? 7. This was idea of correctness, of Dijkstra correctness. Let me consider the next algorithm. For Bellman-Ford in English literature. So in previous I forgot that we don't have negative cycles in this algorithm, in this graph, because if you have negative algorithms, really negative cycles, we have infinite loop. I think we have infinite loop here. That's why this algorithm doesn't work for graphs with negative loop. And let it be assignment. And you will get 1 point for this. Do you have questions? Do you have questions? How long? Okay. Okay. Так, the next algorithm. I mean, in this case, in this null key BFS algorithm, we consider this function that works for null 1 to k. In this case we have this function k, and the Dijkstra algorithm works only for graphs with non-negative cycle. In Bellman-Ford algorithm, we can consider negative cycles. So we have e to r function, and we need to find again distances from S to all vertices. And here we consider solution with dp approach. Так. What is dp will be? What will be dp? It will be like dp key. It will be 2D array. In this array we store mean lengths of paths S to V, which contain only less or equals than k edges. Less than k of edges. Okay, base is dp v with null h equals to null if v equals to s, and plus infinity if v or otherwise. This will be some kind of relaxation for dp. And step, some kind of initialization, single source initialization. And step. What will be step? We contain to dp, we consider dp, and we try to calculate like k plus 1. No, notice just we have the sign where we have the sign, so we need to push dp for v to k, and what? Minimum of v belongs to e, and okay, we just consider minimum of u, okay, and plus it to cost of uv. That's is very easy to pair. So that's all the algorithm. We have to calculate the pair and we get the answer. But we consider negative cycles in this algorithm, and notice that that J, if J hasn't negative cycles, if we know that J hasn't negative cycles, we use this algorithm because the Dijkstra algorithm, because complexity of Dijkstra algorithm is no O m log n, and in this case we have O m n, да? O m n, because the pair contains we drew the step for O1, and the pair contains the pair array is Vn, where is m n size. So Vj hasn't negative cycles. That means we must to calculate only the pair n-1, because no, but the pair not -1, the pair, and we get the answer because if you have n vertices, it means we have to if it means shortest path, it means every path will be contain only n vertices. Only n vertices. Так, so note, if C negative cycle, it then exists where? In S, in C. That for this where the PVN less than the P v n-1. Why is it true? Who can answer? Okay, nobody. So we consider some negative cycle, C, and we consider where. So so we get that if we have negative cycle, we just here we just we can do infinite loop in this cycle, and we get the pair less and less. And if we have n edges, it means if you have n minus 1 edges, it means if we consider the pair n, if we consider if we consider walk with n edges, it means it contains. It means if we have cycle, we have that we negative cycle. It means we pass the cycle and get some and get less sign. Do you understand or not understand? It's Dirichlet theorem. Just school theorem that we consider n cases and этих n boxes and n plus 1 rabbits, and we get that one rabbit doesn't we have box with two rabbits. For example, this theorem, just we consider we get that if we have n minus n vertices and n minus 1 edges between them, we get that one edge will be will be extra, and we get that we pass some edge twice. Ладно. Maybe in English literature it's called in other way. So how to find negative cycle? Just launch BFS, we launch BFS for all these ZLs vertices. Vertices where we get that dist as SW equals to minus infinity. I mean, if we have this, we check for every vertex this condition, and for all of these vertices we try to we launch the BFS, and we launch the BFS and all vertices that reach it from vertex where we notice as minus infinity. we mark as minus infinity, because we can do infinity loop, and get and reach some vertex that we have some walk from that to this vertex, and all these vertices we mark as infinity, minus infinity. No, shortest path we from to this vertices we mark as minus infinity. So do you have questions? I hear somebody. Your microphone is very quiet. Can you ask question in chat? Okay, I didn't see questions, but I have a questions to you. So I turn off translation if you have any questions.